Hello, everyone, again. I hope we hear each other. Cool. Welcome to mDevCamp again. Welcome to iOS Stage. I would like to especially thank to our partners. In alphabetical order is Confirmatic, JetBrains, Kiwi, and MSD, and SmartLook. This year, we are going to go with the Barcamp style, which means that all the speakers who are here today are chosen or elected by you. So it's completely your choice. We had nothing to do with the choices you made, which is super cool. It's awesome lineup. Each of the talk will have 20 minutes length. Then you can follow your speaker to the 3D world where they will hang out for a really long time. So you have the chance to socialize with them, to have further Q&As, and to meet with each other, which is super cool. And we will be really glad if you would engage on social media with the hashtag mDevMeet or mDevCamp. And without further ado, I would like to present our first speaker and our first talk on the iOS stage, which is about development on Kotlin Native and Swift, new technologies and their internals. And our speaker is developer for a long time, been on iOS since iOS 5. Right now is currently working for JetBrains, developing Kotlin and Java. And his name is Aydar Mukhametzyanov. Aydar, welcome.
Hello, thank you. All right. Hello, everybody. And my name is Aydar Mukhametzyanov, as you could hear. And today we talk about new technologies and their internals in development on Kotlin Native and Swift. And in this short talk, we will talk about only tooling and technologies, but not about memory model or concurrency in Kotlin Native. Short introduction about me. I was an iOS developer since 2012, and in 2019, I joined JetBrains, the AppCode team. So Kotlin Multiplatform is a technology which allows you to share the same Kotlin code between different platforms. Currently, we have 3 platforms. It's JVM, it's JavaScript, and Kotlin Native. And if you just remove this JavaScript part, then you get Kotlin Multiplatform Mobile. So it's just called like that. And we have a team in JetBrains, KMM team, which developed the Kotlin Multiplatform Mobile plugin for Android Studio. And this plugin is very useful. And you can create a KMM project so through the wizard. And also it allows you to run, debug, and test iOS applications. So additionally to development of Android application, it allows you to run iOS application. But this approach, this solution also has some problems for iOS developers. First of all, Android Studio doesn't support Swift or Objective-C. So if Kotlin is highlighted and shown very nice way, but then for Swift, you see just like basic highlighting, and you don't have auto-completion, you don't have anything. Another problem is that it's caused by the way how Kotlin framework is integrated into iOS project. It's integrated as a binary framework. That means that to make this Kotlin, like shared Kotlin logic available in iOS project, you have to build this shared framework. So you have to wait, you have to first have compilable Kotlin code and build it, create this framework. And also, whenever you do any changes in your Kotlin code, you have to rebuild your framework to make these changes available in Swift code. And you get this circle of development that you change code, you build the framework again, and then you can use it. One more problem for iOS developer in KMM is that there is a huge gap between declaration of anything in Kotlin code and usage of this, for example, class in Swift code. And if you try to, for example, navigate to this from Swift file, you try to navigate to the declaration of my class, you will not be navigated into the Kotlin file and into the Kotlin declaration. For example, here is just a part of generated header of this shared Kotlin framework. It doesn't look pretty. Of course, you can generate Swift interface from that, but it still will be only interface. It won't be any. You will not see any internals or what happens inside the function or inside the class. Or you could also find this declaration by old good Ctrl+Shift+F, so just by text search. It's not, in large project, it's not very efficient, but still works perfectly. So to summarize, what problems did we get there? So we have lack of Swift and Objective-C support in Android Studio. We have necessity to rebuild your Kotlin framework every time you make a change. And also the huge gap between declaration in Kotlin and usage in Swift. And in ideal world, would be very nice to make these two worlds closer to each other. So Android Studio doesn't support Swift and Objective-C, but we have AppCode, which does it. And that's why all our new development in this direction we do in AppCode. And let me introduce Kotlin native plugin for AppCode. Actually, it's not new. It exists since 2018. And initially, it was supposed to help people, to allow people to develop on Kotlin native inside AppCode. So it just supported Kotlin language as language, so highlighting of the completion would work. And also, you could run and debug iOS applications, so you could debug Kotlin code. Also, there is an integration. There is some nice wizard to create default iOS project with already integrated Kotlin native framework. And this is how it looks like. So you see it how, for example, Kotlin native code is debugged inside AppCode. And all of these technologies were developed in 2018. And you still have, even there, you still have this circle that you have to build your Kotlin native framework first, and then it becomes available from Swift, from Swift code or from iOS project. And in the latest release of Kotlin native plugin in 2011, we resolved this problem. And let me just do a quick demo how it works now. So here you see just the project. First of all, it's an AppCode, and here you see, let's see the structure. We have Hello Kotlin folder. Inside you have Swift files, some app delegate, Kotlin view, etc. Also, there is this magic folder, Kotlin native framework, which actually is not Swift or Objective-C folder. It contains Kotlin file. And you see, if you open this Kotlin file, there is a simple class, Kotlin native framework with hello string. And let's see, for example, how we use it. So we have this framework, Kotlin native framework. And if we try to navigate there to hello string, we navigate directly to Kotlin code, so to the Kotlin declaration. Also, you could, for example, find all the usages of this hello string. So you see, you work like if it would be just one language. Also, it's possible to add a new property. And you see that it's immediately highlighted as unused. And if you go back to app delegate, and I didn't build anything, and this additional hello directly available, just becomes available in completion. All right. Also, what is possible? You can do some refactorings. You could rename this additional hello, and rename happens inside the usage, and declaration is renamed. So that was a short demo of what is possible now, and let's see how it's built under the hood. So let's start with symbols. Symbol, it's an internal representation of any declaration inside your project. And IntelliJ IDE, they collect symbols into symbol tables. And if you take all the symbol tables, it's like what IDE knows about your project. And usually symbol contains information like name of function or of a class or something, where it's located, in which file, in which line, etc. Some attributes, relationships with other symbols, for example, some superclass or anything else, etc. And for Swift, just a short example, for Swift, if you have this Swift file with class person, and then symbol table for this class would look like this, something like class, properties, function, which returns void, etc. If you want to know more, you can watch my last year talk on NSPain about AppCode, how it works. And there you can find a lot of insight, even if you don't use AppCode, actually. So to be able to work with two languages, as if it would be one language, you need to implement cross-resolve between them. So you would need to be able to translate symbols of one language into symbols of another language. So, and with Objective-C and Swift, we do it by using naming rules. So naming rules you can oversee inside official Swift repository. And there you can see how, for example, you have to transform Objective-C symbol into Swift symbol, so it would look like how it's supposed to look like from Swift. And for implementing, but cross-resolve between Kotlin and Swift implemented a little bit different. Let's see how it's done. Let's imagine you have a hello string in Kotlin, and it's like a symbol, and you want to get this Swift symbol. So it's like a representation, how it would be represented in Swift, and how it used to work. So you have existing Kotlin symbol, you have desirable Swift symbol. And you can't go directly from one point to another because there is a very, very dark forest between them. So you go to Kotlin compiler, ask this Kotlin compiler to build the project. Then Kotlin compiler generates Kotlin framework, this shared framework. It's a binary Objective-C framework plus the header, Objective-C header. And we read this header, parse it, and create Objective-C symbols. And then we translate these Objective-C symbols into Swift symbols. That's how it's used to work in previous versions of Kotlin native plugin for AppCode. Let's have a closer look into Kotlin compiler. What does it do? It takes Kotlin code. Then Kotlin frontend generates some module descriptors. It's like internal structure of your Kotlin code. Then, depending on the platform you want to build this code for, the framework, whatever, you give it to particular backend. So in our case, we give it to Kotlin native backend. And Kotlin native backend generates from module descriptors, it generates Objective-C framework with a header. So, and if we have closer look again to Kotlin native backend, we see that it's just a machine of transforming module descriptors into the framework. And before, it was translating, it was creating Objective-C header directly from module descriptors. So it would read these symbols it had and translate it, just generate text directly to this header. And what we introduced an additional layer between module descriptors and generated header, which would represent Objective-C symbols. And we just, from these internal structures, like intermediate structures, we could get real Objective-C symbols. And these Objective-C symbols could be translated to Swift symbols. And if you look at this from the top, then, so what is on top, then that happens on Kotlin compiler side. and what is under the line happens on AppCode's side. And now, how this translation process look like? You have this Kotlin symbol. Then you generate some internal compiler structures. From that internal compiler structures, you generate Objective-C symbol, and then you generate Swift symbol. And this, so you just go, instead of going like this before, you go directly from Kotlin symbol into Objective-C and Swift symbols. That is possible because we introduced these internal structures in the new version of plugin. So what advantages we got? First of all, all updates happens on the fly. So do you remember I told that whenever you change your Kotlin code with the old approach, you had to rebuild your framework. So it would be so symbols from Kotlin would become available in iOS project. Now, whenever you change your Kotlin code, module descriptors are updated as well, and we update our symbols as well. As you've seen in the demo, I didn't build anything. I just added this additional hello, and it appeared in completion immediately. Then, because we have symbols, but not just Objective-C file, Objective-C header, we have symbols, and symbols, they contain many information like location, for example. We can implement code to declaration. We can implement all the refactorings, renamings, etc. You find usages. So just we are able to support this language fully, let's say. And one more very, very important advantage is that with old approach, you would need correct code. You would need to have correct Kotlin code to be able to build Kotlin framework. Because when you run compiler for building framework, it runs in mode when it if it meets any error in your code, then it just stops. So, and in your approach, compiler tries to recreate their state if it meets the error in your code. So functionality and compilation still will work, even if you don't have compilable Kotlin code. As conclusion, I would say that so my team, as I said, and it's obvious that my team work on making Kotlin Multiplatform more friendly to iOS developers. And in future, it will become more and more friendly. Also, cross-resolve between Kotlin and Swift, you can already play with it in Kotlin native plugin for AppCode. It's available, already released. And also, as an iOS developer who started working with this Kotlin Multiplatform, in the beginning, I struggled with Gradle. So if you want to do Kotlin Multiplatform development, I really recommend you to learn Gradle. Don't be scared of it. It's complicated, probably. It's huge and big. It's like ocean of everything, but it's still doable. And just ask your Android colleague. Okay, that's it from my side. Thank you very much for listening. Here you see Twitter of AppCode or my Twitter account. Just write me or write to AppCode account. And also you see the list of topics we were talking about. So if you have any questions, see you in the discussion zone. Thank you.
Thank you very much again for your talk. It was great. I encourage everyone who would be interested in further information and further detail to follow your speaker in the 3D world. I would also like to remind you there are some similar competitions or quests going on in the 3D world at the MSD stand, at the Kiwi.com stand, and SmartLook. And please use your social media to tweet and to engage. And I will see you in like a half an hour for another speaker on the iOS stage for Pavel Jacques.